Recording now. All right, we're here with the AP Stats class talking about chi-squared tests. All right, now just to give you a quick little run through about what the chi-squared model is, we have already talked about two models. What models have we used so far with inference? Z comes from the normal model, and T comes from the T model. Excellent, very good, right? This is a normal model. So the third model you need to learn, these are the three you have to know for the AP exam. This one is the chi-squared model. All right. Now, this is going to be about categorical variables. All right. Last test that you just took was about averages or means, which was quantitative variables. Now we're going to talk about what to do when we have categorical variables. Remember that from chapter 3. Yes, categorical, no units. All right, so we're just counting. All right, and in this case, we're just counting the number of M&Ms. So here in this table, we have our counts for all the different colors of M&Ms. And I want you to compare it to what the company is saying for us, which is they think it's these percentage. All right, so the test we're going to run today is called a goodness of fit test. I know that if you read the chapter, that's badness of grammar. But this goodness of fit test basically wants to know how good a fit is our data to this model, what we think is happening. All right, that's all this test is. This right here is what, in theory, what should happen with every bag of M&Ms. We want to know if our massive bag of M&Ms is in line or fits with what the company is telling you. That's all we're doing. All right, and we're going to use something called the chi-squared model, because you'll notice this variable for number of M&Ms is categorical. There's no units. It's just count how many red, count how many blue. All right, so let's keep going. You're going to start writing here. Yes, everybody's ready to start writing? All right. How would I want to do this? I don't want the pen. Ooh, select. No, I thought that was sad. How do I just grab it? Oh, I know how to do it. You know what I need? Jesus. I need Jesus. Yes. No one's going to watch this video. No, I was just joking. Nicole better watch it. Let's get this. See ya. There we go. Now it's gone. Woo! We got it. V for victory. Like Liverpool when they beat Barcelona. Ah! Oh man, and I went to the next slide. That's not what I want. Okay, so the first thing you should notice, I know you're about to write, all of you are about to write the hypotheses. The first thing I want you to notice is that these hypotheses have no symbols. Do you see that? You guys are all like writing like robots, but if you just take a moment and look, you're writing a sentence. Did we ever write a sentence for our hypotheses? No, this is the first time. I know. So you'll notice this is what we're doing here. And I put here at the bottom that we're never going to have to define parameters. You don't have to define any parameters, and we're not using any symbols. We're just going to write in sentences the hypothesis. And you can see this is what we just said. We think that the distribution of candy colors of our sample is as the manufacturer is claiming. All right, so we think right now our null hypothesis is that our sample data is going to line up, is going to fit with what I expect to happen from those percentages from the manufacturer. The alternative is that it doesn't. It's not a good fit. It doesn't line up. Is there a question? No question? Okay. Any questions on the hypotheses? Yes?
So can it also be like, so you know how like we have greater than, less than, or like not equal to?
Great question. So you're going to see when we sketch it, because we're going to draw a sketch of the chi-squared model, I'm going to show you on the internet what it looks like. You're going to see that it only looks like it's one-tailed, but because I just want to see if it's different, George, I want to see if there's a difference between our sample data and what we think is going on. So it's actually, in theory, a two-tailed test. Even though when we sketch it, it will look single-tailed, Thanks, guys. I think they're cheering for you, not for me. No, it's me. Because you came back. Thanks for coming back. All right.
Wait, so kind of adding on to George asked, I don't know if this is what you meant, but so would you change the way you write it if it's either like not equal to or greater than or less than?
It's the same, right? You'll notice I'm not saying I think some are less or some are greater. I just want to know, is it a good fit or is it not a good fit? That's it. So that's all I'm looking for. All right, you're going to see when we actually do the calculations, the mechanics, if you will, that some are going to be more or less than what we thought. All right, we're basically comparing what happened to what we expected to happen. That's what we're going to compare. Can I go to the next slide? Excellent. Let's go to the next one. Oh my goodness. All right, this video is going to have music brought to you by Kevin Chavez. I almost was going to say that, but I didn't. I wasn't sure it was yours, Kevin, so I didn't. All right, here's some conditions we need to look at. Now you can see we have the same independent assumption with our two conditions associated with it. This has been the same. This has been constant every test I've ever taught you. All right?
Will it continue that way?
It will continue that way
Okay, so
till the end. All right, so we're assuming that if I tell you that I have this many red, it's not going to affect how many blue that I have. All right, if you went to Target or Walmart or wherever and bought a big bag of M&Ms, we have no reason to believe that there should be any issues with that. You'll notice on the statement you're writing for the randomization condition, I just hope that the bag of M&Ms that I have represents all the M&Ms that they make. That's what I'm hoping. So that's a statement you'll see a lot this week. Is everybody good on where I got the 3,350 number?
Yes, from the first one.
So our sample size is 335 M&Ms, and I multiplied that by 10.
What if you're working with something like straight out, plastic filter or whatever, and you're not exactly sure if it's accurate, it's like, oh, that's more than 10% or whatever.
Well, what you can always do is you can go forward even if you're not sure, and then when you analyze your results, that's where you have to decide how unsure are you. Should I use what the report is telling me, or should I not? We're never going to know for sure. That's the hard part about it. All right, you'll notice a new condition. Do you guys see the counted data condition? This is a new condition. We have to make sure, basically, you're making sure you have a categorical variable. Because if you don't have a categorical variable, you should not be doing this. All right, so you just think, are we counting in a category? We are, yes. We're counting by color of M&M. Any questions so far? All right, let's keep going. All right, a few more assumptions and conditions. I'm going to actually just do this one for the sample size assumption real quick. And then we're going to talk about how to get the expected cell frequency condition. So we're assuming that our sample size is large enough. Any ideas how I'm going to figure out my expected values? Any ideas how I'm going to figure out the expected values? Well, while you're writing, let me just remind you that the very first slide, don't worry, I'm going to come back. The very first slide told me what about the company? What are they claiming about these M&Ms?
Color candy.
13% red.
Oh, yeah.
24% blue. You see all the percentages? So how many M&Ms do I have? 335. So if I take 335 and multiply by each of those percentages, that should give me the expected number for each color. So that is what you're going to do for the expected This last condition, the expected cell frequency condition. Take a look at this. All right, so if you're wondering, Mr. Vendrick, where did you get that number? I took 335 and multiplied by all of those percentages. Should I write out the work that I did?
Yes.
Would that be helpful? All right. What was red? Ooh, man, it's going to give me so many likes. Times. What'd you say, Marcel? Okay. Red was 13%. So if you have a calculator right now, you can do 335 times 0.13 and confirm that it's 43.6. You didn't confirm. You don't need to believe, you can confirm. You can trust me, but it's also nice to confirm.
Yeah, you're right. 0.55.
So I rounded to 6.
Yeah.
All right. What was blue? What was the percentage for blue?
24.
So 0.24. All right. You can confirm that that's in fact 80.4.
So every time that we run one of the.
You need to calculate the expected values. Uh-oh, I don't have an orange. Maybe it's in the calligraphy pen? No. Crayon? I have an orange crayon, maybe?
Yeah, that's yellow.
You know what, guys? What was the percentage for orange?
20.
Marcelo? 0.2? Yeah, I'm not going to do a crayon again. That wasn't helpful. Let's just use the regular pen.
Can we do this in like listing spreadsheets?
Ooh, interesting thought, George. Could we do this in listing spreadsheets? I wonder where we're going later today. Yes, spoiler much. Okay, field trip. Green. To the Tesla place. What's the percentage for green?
16.
16?
16.
And then I think I have a yellow.
14.
Yes, I have a yellow. What's yellow?
14.
I don't think I have brown.
Yeah, you do.
I do have brown? No.
Hey, isn't that the last one?
Yeah, it's like dotted.
That's the one where you use.
Third one's red.
What you use for oranges.
I went orange, I used black, guys. Oh my gosh. What's brown? What is it? What's brown? What percentage is brown?
13.
13%? Oh, George, that's okay. All right. How are we feeling about that so far? You'll notice that the expected cell frequency condition says they need to be at least 5 in each cell. When you look at each cell, they're way more than 5. So there's no problems there.
So does both points tell you what you should do or like what you're supposed to have?
You should write, you should say, like you should do it, write the table, and then say, I see that each cell is at least 5. That's what you're writing. Yes, is that what you're saying? No? I'm sorry. Where did I get 5 degrees of freedom from? Very good. There's 6 categories. So categories minus 1 is 5.
That's where the I should skip it.
No, sorry, that 5. No, you're good. You do this. Are you good on how we got these numbers?
Yes.
So all of these numbers added together will give you 335. I expect when I open my bag of M&Ms to get this many of each color. Obviously, I can't have decimals, but basically that. I need them for our sample size to be enough. I need these cells for the expected values to be 5 or more. Otherwise, my sample size is not large enough. It's the same idea when we did the n times p and the n times q. We're looking for them to be 10 or more, so it makes us feel good about our sample size being large enough.
Similar to like the histogram, right?
Well, we're not doing a histogram. Histogram is for what? Histogram is for a quantitative variable, and this is not a quantitative variable. Sorry? Oh, what? We're not going to do any graph. We are going to do a curve, right? What do you mean, the curve? We did a curve with the t-test. Okay. Jacob. That's fine. You're going to watch the video later, catch up on what you missed? Okay. You're going to comment and like and subscribe? You already a subscription member? Thank you so much. I appreciate it. All the money I get, thank you so much. Appreciate that. You didn't hear what he said as he walked out? He said, I'll be one of your 2 likes.
I'll make it out there.
What was it? What's the name of your SoundCloud thing? Can you do comments on SoundCloud? Yeah? Okay. You can dislike it? How many times can you dislike it?
7.
Okay. Now, we are ready for the meat of it. The meat. Like the math. We're ready for the bulk of the math here. All right. A couple of things you need to notice. This right here is not x squared. This is chi squared. All right. This is the Greek letter chi. Chi squared. C-H-I squared. There you go. It's fancy. It's chi squared. Okay. Chi squared. You'll notice here's how we're going to calculate it. Absurd values. This is what we actually have. So let's look at how many red did I actually open and see and count.
Do you do that for every single?
Yes, right? How many?
57.
57. So 57 minus how many did I expect to see that would be red? 43.6. You're going to square that. Why do we square it? Well, yes. But why do I square it? Because on that one, we're going to have a positive value in our numerator. But could we have a negative? And when we add positive and negatives, they're just going to start canceling each other out. So how do we avoid that? We square everything, because then we know everything's going to be positive. All right? Divided by the expected value. Or,
How? Figure out the square though.
Okay, fair enough. So, I've already written down all of this work so you guys can see how much work you got to do. Here you go. All done, Chris? Excellent. Thank you. Perfect. Thank you so much. All right. So you can see this one for red we already did. We already did this for red. You're going to do it for blue and all the colors.
Is there a way of doing this on the calculator?
Yes. We'll show you how to do it on the calculator where it's much faster. And just like with the last test, I will make another document that has the button pushing. All right. Was that helpful? Okay. Now, I know you guys are in the middle of copying this down, so I'm just talking to myself here. But after you find each individual chi-squared component, you'll notice that we have a summation symbol here, which means to add them all up. All right, so that's what this symbol here means, to add all the numbers. So this thing that I haven't shown you yet is going to be the chi-squared value, adding them all together. All of them.
Why would you add that?
The reason we add them together is because we're going to use that as our test statistic. So when I show you what it looks like when you draw the model, like the actual curve, the p-value will be based on this chi-squared test statistic value. So this is, remember we had our z-score, our z-value, and our t-value? This is it. This is what we're looking for. You're looking for chi-squared and p-value.
It makes it easier when you compare it to like.
Right? I mean, that's what when I teach this every year, I get a lot of students that are really worried because there's a lot going on. But what's nice is you have so much to fall back on, and that we're not really changing the game that much.
So is this your chi-value?
Chi-squared value. Chi-squared value. All right. We ready to see what the chi-squared value is? It's just adding them all up. It's not really a mystery. Okay. I don't actually know what it is. Yes, I do. It's 13. All right, so 13.164. Now, I'm going to do like a little sidebar, and I'm going to show you what this looks like when you actually draw the curve. So let's do chi-square applet. University of Iowa. Love this university. All right, can you guys see that? Try to blow it up more. Is that better? Okay, how many degrees of freedom? 5. What is our chi-squared value? 13.164. There's your p-value. Now you'll notice, do you guys see that the curve is showing skewness? That's how you should draw the chi-squared model. You should draw that on the next slide. Do you on the next slide where it says p-value? To the right of that, you should have enough space to draw that curve. To the right of that. Let me show you what I mean. You're drawing it right here. Okay, so you should be drawing that to the right. Now, do you guys see what I was saying earlier? Do you see how it's only shading in one direction? That's how it will always be, but I'm trying to tell you that even though it looks like a one-tailed test, it's really not. Right? It's really not. It's really about, is it just different? But when you shade for a chi-squared model, that's how it should look. Now, I wanted to show you for fun. I know most of you probably won't think this is fun, but, someday. So what if my degrees of freedom, instead of having 6 categories, what if I had more categories? What if I had 10 categories? What would be my degrees of freedom? 9. What happened to the curve, even before I put in a chi-squared value? It shifted. It made it look more what? More normal, less skewed. Let's do another. Let's try 19 degrees of freedom. What is it making it? It's making it more normal. All right, so every time you do this, you're going to make it more and more normal. Look at that, almost looks normal. I mean, it doesn't, right? But it's closer. Jacob? Yes, infinity. But we'll never get there. All right, so I think we saw the p-value, right? What was that p-value?
0.022.
Excellent. So what are you going to write for your conclusion? A p-value of 0.022 if we're using our traditional alpha of 0.05. We're going to reject the null. We're saying there's enough evidence to do what? What are we saying here? That our data is not a good fit, right? We're proving with our sample that we don't think that our sample lines up with what the company is saying should have happened. All right, so let me show you a couple of answers here so you can write these down. You'll notice this is my go-to. I put no context and then context. And as I have told you guys about the hypothesis test, always refer back to what you wrote for your hypotheses. All right, in our hypothesis, we said that the alternative is that it's not a good fit. So that's ultimately what we're going with. All right, once you finish writing, if you would like to follow along, we're going to do this in the calculator, the Inspire. So it doesn't matter, right? Because this is whatever direction, it doesn't matter. We're not worried about what tail we're shading. Just always shade the right tail every time you do a chi-square. You're going to see with the calculator, it doesn't even ask us to give like a less than, greater than, or not equal to. All right, are we ready? Yes, ready for the calculator? All right, so I expect if you are wanting to learn the calculator, you have it out, and you're following along with me. We're going to do a new document, and we're going to add a list and spreadsheet. The first column is going to be my observed values, OBS, for observed. So I want you to type in those observed values from the very first slide, which were 57, 79, 75, 57, 41, and 26.
So we do this after we know the numbers?
Say it again?
When do we do that?
When do we do what?
After mechanics, after cost?
So no, okay, good question. That's a really good question, Marcella. When would I go to the calculator is what you're asking? I would write the hypotheses, write the assumptions and conditions, go to the calculator. Now you'll notice in one of the conditions, you need to check the expected values. So you might be going to the calculator near the end of your assumptions and conditions. That's a really good question. Now I'm going to use for the next column, expected. EXP, I doesn't like that. Let's do expected. The whole thing, expected. Now, when I go to the first one, you could type in the number we found, or you could do a little math, equals, what was the percentage for red? 20 or 13? 0.13 times 57. And it will do it for you. That's not right. What I do wrong? Oh, not times 57, Douglas. 0.13 times 335. So does everyone see? You could type in your own 43.6, or you could have the calculator do the math for you. Just make sure you hit equals, equal sign. It's, thank you, right under control. So I'll do it again. Equals 335, and then times, and I'm doing the next one now, times 79. That didn't look good. Douglas, what are you doing? Good Lord. Take a moment, read the problem. There we go. My fault. Times the percentage. Times 24% for blue. All right, let me see if I can do orange without messing up. Equals 335 times 0.2. It's a miracle. Okay, next is green. 335 times 0.16 equals 335 times 0.14 equals 335 times 0.13. Now, what some students do is they just do this all like separately on like a calculator page, and then they wait and they go to this, and then they'll type in what they did. Like they'll do, I'll show you. Doc. Insert calculator. They'll do the math separately, like 335 times point, kind of like what we did, and then they write it down, then plug it in. Doesn't matter. Whatever you want. Okay, so are we all good with the two columns? Everybody have the two columns? I'll pause. Just let me know and I'll pause. Okay, I'll pause. Yes. What? Scroll down. Better? Yeah. Tanya, see good?
Yes.
Okay, everybody good now? Kevin good? Yes, good, good, good. Okay. All right, here we go. So, doc, insert, calculator page. Doc, insert, and don't worry, I'm going to put all this in that document, okay? If you forget. Doc, insert, calculator. Menu, we are in stats. We're running a stat test, right? Chi-square test. And you guys see number 7, where it says chi-squared GOF? Goodness of fit. Goodness of fit. All right, number 7. Observed list, obs. Expected list, expected. Degrees of freedom? 5. And hit OK. No, sorry. I know. Now, you'll notice we have chi-squared. We have p-value, which we already knew, and degrees of freedom. So that doesn't really, I mean, we already wrote those down, but now you can see how you can get them in the calculator. Now, here's where I'm going to blow your mind whole. You ready? No, you're not ready. Vincent, you say you're ready? No, you're not. Okay, so don't touch anything. Ready? Don't touch anything. I didn't say put your hands up. Okay. Do you guys see where it says VAR? You guys see where it says VAR? That's for variable. Watch what happens when I click it. And you see where it says stat.computational list? Ready? You're not ready. Enter. What are all those? Those are the individual chi-squared values. Thank you. Thank you, guys. Right? At least, there are at least a few students in here that were like, oh my gosh, I can get each of them. Now,
It'll be first after you do the.
Correct. You got to do the whole test first, otherwise. And you'll notice it's telling you here, hey, you should take a look. You should take a look. Now, what I want to make sure you look at, and we can look here because you have them written down. What you're going to be asked about potentially on the AP exam is what's driving the 13? What is driving this 13 number? It sure isn't blue. Right? Blue is really close. It looks like brown and red. We had more red than we thought and less brown than we thought we would get. More red than we thought, less brown than we thought we would get. All right? Those two colors are what's impacting. What? That's 11? That's 11 of the 13. All right? So keep that in mind. They might ask a question down the road about, what's the main thing contributing to your chi-square? Questions?
No, sir.
Yes, Roberto.
Why did you say less brown?
Why did I say less brown?
Because you're observed.
Remember, the formula is observed minus expected squared over expected. Nope. I already forgot. You have to watch it, Jacob, when you watch tonight. All right. Yeah. Yeah, that's fine. Because, Roberto, it's 26 is what we actually found in our bag of M&Ms. And that's less than what we expected. We expected 43, 44. But with red, we only expected 44, but we got 57. So, but you'll notice you didn't know that because it was squared, so you just see the positive values. But if we hadn't squared them, then we add them together and it just starts canceling out. That's why we square them. That sure seems like time for me to stop. Any last minute questions on chi-square tests? So we have 10